Good morning, good afternoon, and good evening to wherever you are in the world today. I am Sinead Leahy. I'm the Principal Scientist at the New Zealand Agricultural Greenhouse Gas Research Centre, and we're really delighted to welcome you to today's webinar. The State of the Science webinar series is hosted by the New Zealand Agricultural Greenhouse Gas Research Centre, and today's webinar is in partnership with the Teagasc Climate Centre in Ireland. So making sure you have access to some of the best local and global experts when it comes to agricultural greenhouse gases. Please note, we have a number of exciting webinars planned throughout the year, so keep an eye on our socials for more information. And it really is a great lineup of expert speakers today. We are also really lucky to be joined by the NZAGRC's Chief Scientist, Dr. Harry Clark, who will be your chair and who's going to take you through today's session. So welcome, Harry, and I'll hand over to you.
Thank you, Sinead. And just to repeat Sinead's welcome, morning, afternoon, evening, wherever you are in the world. Many thanks for joining this webinar. Now, understanding methane emissions from cattle is very important globally, and understanding them from grazing cattle is a much neglected area of work. And it really is important to understand emissions from grazing cattle. They make up a large proportion of methane emissions globally, and they're very important for the accurate accounting of greenhouse gas emissions. And two of the countries in the world where grazing animals are very important are both Ireland and New Zealand in temperate grassland systems. And so New Zealand and Ireland researchers, funded by their respective governments, have been working together to determine how things like the stage of lactation, pasture species, pasture management, seasonal growth effects affect methane emissions, and very importantly, how these factors can influence an animal's response to methane reduction technologies. And as part of today, it's really my pleasure to introduce Ben Lahart from Teagasc in Ireland and Jane Kay from Dairy NZ in New Zealand. Ben completed his PhD on predicting feed intake in dairy cows through the University of Dublin and Teagasc in 2020. And subsequent to that, he started a postdoc looking at enteric methane emissions from dairy cows, and is now a research officer at Teagasc working on methane emissions from grazing animals. Jane's had a somewhat longer career. She's had in excess of 25 years now working on dairy cow nutrition and dairy-based pasture farm systems. She's currently a principal scientist at Dairy NZ and leads their reduced GHG emissions research portfolio, which aims to understand methane emissions and develop viable and scalable mitigation strategies for pasture-based dairy systems. Now, it will be a bit of a tag team, this one. I think they'll be swapping places and swapping leads throughout the talk. And so I will hand over to them. Just one word, we will have plenty of time for questions at the end. Can you please put your questions in the Q&A, not in the chat, please? So on that, I'll hand over to Ben and Jane. Thank you.
Thank you, Harry, for the introduction, and thanks to NZAGRC for the opportunity to present today. I'm just going to share my screen. This worked perfectly well before, but we all know that when you try and do something when you need to, it doesn't always work well. So Ben, maybe you can just give me a thumbs up if you can see.
Yeah,
see that.
good,
okay.
Jen.
Yeah, perfect. Thank you. So as Harry said, today we're going to talk about seasonality and enteric methane emissions from pasture-based systems. So just a real quick background. Many countries, including New Zealand and Ireland, are facing targets to reduce their greenhouse gas emissions. And these are both national targets and also market-driven targets. Because of the contribution that methane makes to the greenhouse gas emissions in these countries, we need to develop viable and scalable methane mitigation strategies, and these need to be specific for our pasture-based systems. When we think of these mitigations, we can group them into sort of three key categories, and that's technologies such as your vaccines or feed additives. We also need to think about feed, and this might be feed where we need to understand the base emissions. We also need to understand the response to technologies when animals are grazing or eating these different feeds. There's also work in the genetic space, selective breeding for low methane animals, and also in the plant area where they're looking at breeding high lipid, high ME ryegrass or high condensed tannin white clover. In this webinar, we're really going to focus in on the feed. So there's numerous data sets out there depicting that relationship between feed eaten, so dry matter intake, and methane production. This is a graph from Stefan Mutzel and colleagues' paper, where they've looked at that linear relationship between kilos of dry matter intake on the x-axis and methane production on that y-axis. Now, this is data from growing or non-lactating animals, and these animals tend to eat about sort of 10 kilos or less. Then we have lactating cows, and these animals are sort of sitting higher up in that graph, eating that sort of 15 to 20 kilos plus. There's no sheep on this graph, but for those sheep farmers out there, they tend to sit down at the bottom of the graph there, eating about sort of 1.5 kilos of dry matter and producing sort of 27 grams of methane. So based on this relationship between dry matter intake and methane emissions, they've developed calculations. Now, we can't measure methane out on commercial farms or at a national level, so we need these inventories and these calculations to be able to predict or estimate emissions at a farm and a country level. So based on these relationships, there's a standard methane conversion factor that's used in these calculations. So in Ireland, this is based on the IPCC figure, which is the Intergovernmental Panel on Climate Change, and that assumes that 6.3% of the gross energy intake of the animal is emitted as methane. Now, in New Zealand, a collation of data sets by Harry and the team back in 2008 was used to derive a country-specific emission factor, and this predicts that for every kilo of dry matter intake that the animal eats, they produce 21.6 grams of methane. What we know now, though, is with more research occurring, is that, and particularly in studies where we're actually measuring methane and measuring intake, although methane is linked with dry matter, there are cow factors such as cow breed, stage of lactation, and their level of intake. And there's also feed factors such as the type of feed, quality of feed, and compositional changes across the season that are altering those methane emissions. So it's really important to understand these factors, how they're altering methane emissions, so we can more accurately account for these emissions in our pasture-based systems, but also develop fit-for-purpose mitigation strategies when we're trying to reduce them. So, as we said before, it's difficult to measure methane at a farm level and particularly at a national level. So we need these inventories, but we need to be able to measure methane to be able to update these inventories so that they're accurately predicting emissions. So how can we do this? We can do this directly via respiration chambers, or indirectly with methodologies such as SF6 tracer, which is your sulfur hexafluoride, or green feed technology. And these collect a subsample of the gas that's emitted, and then they calculate daily emission production from that. Now, there's pros and cons of all of these methodologies, but to ensure that the data are reflective of our pasture-fed animals, majority of the research that we'll be presenting today is being conducted using the green feed technology. Now, we've done this both in outdoors, so that animals are grazing, and also indoors where they've been fed cut and carry or zero graze pastures. And in all of this research as well, intake's either been predicted using the N-alkane technique, or it's been measured directly. And I think what's really important about this is that when you're using the green feed technology, you need to make sure that you've got good visitations from animals throughout the day, and also really important that the animals and the pastures that are being used are reflective of the dairy systems that are out there. Now, I'm just going to pass over to Ben to talk about the Irish research that they've been conducting in the space.
So thanks, Jane. Yeah, so my name is Ben Lahart, and I'm just going to talk about methane research from enteric fermentation in Ireland, and to really just discuss, I suppose, the outputs from an Irish context and really look into our systems and the enteric methane output in our systems and how it fits in with that seasonal profile so we can have more accurate estimates of enteric methane emissions. So if we go to the next slide there, we can just show you the annual feed intake profile of an Irish dairy cow. So this is a typical cow in Ireland. You can see in the graph there in February, which is our springtime in Ireland. Early spring, the cows will calve down and they will go on to a diet maybe of some grass pasture silage, some concentrate and a small proportion of grazed grass. But as they go into lactation and go out through the main part of the grazing season, the diet is predominantly comprised of grazed grass. So grazed grass is the cornerstone of our systems and it makes up the majority of the animal's annual dietary intake. And then over the winter time, as the cows come to the end of lactation, the shoulder's year, as weather conditions deteriorate, in November, December, January, as you can see there, our winter time, the cows are housed indoors and are fed grass silage, which was harvested and conserved during the main grazing season. So I suppose it's very important from our context to be able to understand how enteric methane is influenced across these different seasonal periods and these different dietary periods as well. So we can just show in the next slide there, across the different seasonal periods, we can see if we look across the spring, the summer, and the autumn, with lactating dairy cows. So you can see that the dry matter intake profile of the cows changes from roughly about 17 kilos to 18 kilos. And actually the composition of the diet that they're consuming actually changes as well. So in terms of the pasture, if you look at the crude protein content, in the springtime when cows lactate and consume a grass-based diet, the crude protein content in a typical seasonal system in Ireland, it will be highest in springtime and it will decrease across the grazing season. The neutral detergent fiber, which is the level of the fiber in the sward or the bulkiness, actually increases across the grazing season. And in tandem with this, the organic matter digestibility, or the amount of, I suppose, nutrients that the animal can extract from the feed, actually decreases across the grazing season. And then going into the winter time, when the cows are non-lactating, their intake will drop considerably because there's lower energy demand, and it'll be fed that grass silage we spoke of previously, and that will have a lower crude protein content, higher fiber content, and be less digestible. So from international research, out there, prominently indoor systems, we would see that diet quality and intake levels have a major role to play in influence enteric methane output. So from our perspective, it's very important that we're able to evaluate and measure methane emissions across these different seasonal periods to generate more refined methane values or methane conversion factors for our inventory. So the first study we did was on the next slide here, where we actually profiled the methane output of a herd of cows across the grazing season. So this is one of the longest continuous profile for seasonal calving cows internationally, and was the first study to this degree done in Ireland, to try to capture the enteric methane output across a full grazing season, or the majority of a grazing season. So if you look at the graph there, you can see in the springtime from the 1st of March up till about the 24th of May, methane emissions from enteric fermentation are quite low in that green bar, and they begin to increase as you go into the summertime, as you go into June, July, and then the peak and plateau in the autumn time. And you can see actually milk solids production has the inverse effect, in that it's highest during this period, in the spring period, and it decreases as the grazing season progresses. So, this is directly related to two factors. So first of all, the cows are in early lactation during the springtime because there are seasonal calving systems, and as well as this, they're consuming a higher quality diet, lower fiber levels, lower NDFs or neutral detergent fiber, and higher digestibilities. And another thing as well that's actually changing across here is that the intake of the cows will be lower in early lactation during that spring period. But even when we correct for the gross energy intake of the cows, as you'll see in the next slide here, and evaluate that against the gross energy or against the energy loss in enteric methane emissions, so that methane conversion factor, you can see even when we account for that effect, the gross energy intake, it's still substantially lower in this study in the springtime. So the methane conversion factor here in the springtime is 4.6%. Summertime it's 5.3, and in the autumn it's 5.8%, and averages out at 5.2% across the year, with a strong seasonal component through this. And then the next thing we did also, we looked at actually calculating the methane output using our inventory models, and we've seen in the springtime there was actually substantial over prediction in the amount of methane produced by the cows. So you can see that in the orange bars there, compared to the measured methane, the green bar, to substantial over prediction in the springtime, and then as the grazing season progressed, it began to kind of diverge, and there was no real difference in the autumn time. So this just shows from a seasonal perspective, inventory calculation models maybe overestimate enteric methane output depending on the different times of the year. So there's an added layer of complexity. There's not one value across the grazing season, so it's important to take and be considerate of that. We've also looked at, in the next slide here, we've also looked at including white clover into grazing swards. So in an Irish context, we're very interested in including white clover into our grazing swards as a means of reducing chemical nitrogen inputs to reduce nitrous oxide emissions. That's one of a major greenhouse gas emission within our systems, similar to all grazing systems. But we also wanted to evaluate the effect on enteric methane emissions of including perennial ryegrass with white clover. So in this study, we had PRG, which stands for perennial ryegrass. So that's 100% perennial ryegrass, and PRG /WC is perennial ryegrass with 20% white clover on average in the sward. And what we found was there was a higher methane emissions with the inclusion of white clover in the sward. So it's not included here, but that was directly related to a higher dry matter intake of those cows consuming the grass and clover swards. And there was higher milk output numerically, and as well as that, when we corrected for methane per kilo of dry matter intake, there was no difference in the methane yield value. So that methane per kilo of dry matter intake, or in the methane conversion factor. So there was no significant difference there. So that just suggests that there's no need to account for differences in sward type in terms of white clover with the inventory based on our data, provided the inventory models are capable of detecting the increased intake from those grass and white clover swards. We've also, in this study as well, it was done across the grazing season, but we've seen no sward by season interaction for any enteric methane parameter, which means that there was no real difference in terms of the grass white clover compared to the grass in the spring, the summer, the autumn. But what we did find, there was still, again, a strong seasonal component in that methane emissions increased from the spring to the summer to the autumn in terms of grams per cow per day. When related to milk solids output, we've seen the same effect. There was also an effect in terms of methane per unit of dry matter intake and in that methane conversion factor, albeit not as strong as the other two parameters, but there was still a seasonal effect noted. We also dug a bit deeper and looked into maybe the biology of what's actually going on internally in the animals rumen. So across the spring, summer, and the autumn, we looked at the VFA profiles, and we seen there was a higher propionate percentage in the spring, which decreased into summer and the autumn. Acetate saw the opposite effect, so it was lowest in the springtime and increased across the grazing season. That meant when you related the proportion of acetate to propionate, it was lower in spring compared to summer and the autumn. And maybe we think what could be going on is that higher propionate percentage in the rumen is acting as a hydrogen sink, and it's leading to less hydrogen being available for methane formation. There might also be a higher rate of passage in the cow's stomach or rumen, which is also likely potentially leading to this lower methane yield values and higher propionate percentage. And finally, at the bottom there, if you look at the archaea, so sorry, Jane, just to go back to the last slide, just the archaea to bacteria ratio was also lowest in the spring, and it increased across the grazing season. So archaea are one of the primary, they're primarily responsible for methane production. So it tallies up that they're lower in the springtime as well. So yeah, this is initial work, and we're looking to do more work in this area on passage rates, rumen passage rates, and get a deeper understanding. So if we just go to the next slide, so the last slide we have on with grazing cows, this is just a study done by Michael Kennedy and Michael Egan here in Moorpark, so it's currently under review, and this just shows that when you have a sward, cows consuming a grass and concentrate sward in the springtime compared to cows consuming grass and silage. With concentrate, there's a higher methane output with that grass and silage, in terms of grams per cow per day, grams per unit of milk solids. per unit of dry matter intake and in terms of that methane conversion factor. So what this suggests to us is that the inclusion of silage into the diet can lead to an increase in methane output. And oftentimes, I think silage and grass are kind of generalized as forage, so they should have the same methane value. But from this research, it suggests that you need to have different methane conversion factors and yield values depending on this. So that's also important from an inventory perspective for use in calculating in the inventory models. So as a result of that, we would recommend having different values for pasture and for silage. But when we look at the next slide, then the average methane conversion factor, this is just I suppose a meta-analysis or a review of different studies that have been conducted in Ireland for grazing dairy cows over the past 20 years using a range of different techniques. We found that methane conversion factor, or the percentage of methane energy loss per unit of gross energy intake, is averaged at 5.8%. So that would say that it's about 8% lower than the value we would currently be using. And that would say it's about 325 grams per cow per day, as opposed to the value at present be about 355 grams. And just a thing to highlight there that there's, as you can see, in terms of the period effects, a lot of the research has been done in the summer and the autumn. There's only 3 studies with spring data in them. So based on previous research we showed, we would see that spring effect. So we're looking to continue to do more measurements in the springtime, as well as the summer and the autumn, so we can maybe have a weighted methane conversion factor across the season. So that's, I suppose, an area that we're currently a work in progress. And the last area I will just speak about is just in terms of our non-lactating period. At the start of the Irish research side, I would have said that over the winter time, the cows, as they're dry, they go in on a pasture silage diet, which is conserved during the grazing season. Their intake will be lower, and they will have a higher intake of, they'll have a higher proportion of NDF in their diet, a higher level of fiber. And we see that the methane emissions per cow reduce, but the methane conversion factor increases. So it goes to 6.5% during this period. So we would, it's due to that lower intake and higher fiber content of that intake, we see the increase in that methane conversion factor. So that would be the value we would recommend for Irish dairy cows when they're indoors on grass silage in the non-lactating period. So that's the end of the Irish research. So if Jane, you want to take over and go through the New Zealand?
Great, thanks, Ben. And we'll just sort of add to what Ben has been discussing with some of the research that's been conducted in New Zealand. So just starting off really quickly, a very similar annual sort of pasture supply demand profile for New Zealand. So during the springtime, we have high quality pasture and high quantity, and often on the shoulders of the season. And this will depend on region, but through the winter period and also through that summer period, we may have a feed deficit where pasture supply doesn't equal demand. Through winter, this tends to be filled with winter crops such as kale, fodder beet, swedes, silage, and also some palm kernel. Same in summer, once again, depending on the region, but if there's a feed deficit, this will be filled with your summer crops, so turnips, silage, palm kernel, and also concentrates through that period. But what we see across that season is a real change in pasture composition, and so it's really important that with those fluctuations that we understand what's happening to those methane emissions across the season. So there was work done back in the early 2000s. So looking at this effect of pasture seasonality. This was paper by Robertson and Waghorn, and this research really highlights that methane emission differences across that season. So similar to Ben's research and what they found in spring, what the methane that was measured, this was using SF6 technology, was a lot lower than what's predicted by using the inventory calculations. And if you overlay the milk production that the animals had through this period, similar relationship again. So higher production through spring with the lower methane emissions. As production decreases, the methane emissions increase. If we move on, I suppose more recently at Dairy NZ, the team here has been conducting a number of component research studies primarily to evaluate mitigation technologies and not specifically to look at pasture seasonality. But interestingly, when we compare some of these studies at different seasons, we're picking up differences in often the control treatment, so the ryegrass white clover treatment, and then we're seeing a different effect of that mitigation technology, whether it was being used in springtime or whether it's used in autumn. So this is an example of some plantain research that Alina Monet and the team have been conducting. What we can see there is in spring, we don't see a methane mitigation effect of that plantain. And this is primarily due to the control diet, so the ryegrass white clover diet, as similar intake, similar methane emissions as what we see with a diet that's got 80% of plantain in it. However, if we look through to autumn, that's when we start to see that mitigation effect of the high plantain diet, primarily due to the changes in the ryegrass white clover diet. So production dropped off, and intake dropped, and then the methane emissions of that ryegrass white clover diet were higher through that autumn period. If we look through to some more component work, this was also done with plantain, and it's been mentioned we're often looking at these other forages for different reasons. Plantain has been investigated to reduce nitrate leaching, but we also need to ensure that if we're going to have a mitigation for one environmental area, that we need to investigate what's occurring with methane. What we can see here is that this trial that was conducted once again in autumn, when plantain made up 40% of the diet, we saw a mitigation effect. Primarily, again, we think due to the ryegrass diet, so lower intake, slightly higher fibre through that autumn period, higher methane emissions compared to the diets that had the 40% plantain in them. Another component study that was conducted in springtime looking at a feed product, and this was a commercial study, so I can't say what that feed product was, but this was conducted during spring. Once again, faced with sort of high dry matter intake, high quality pasture through this period, we see that low methane yield of 17.3 grams of methane per kilo of dry matter intake at this point. So not saying that feed X, as we call it, was a high methane emitting feed, but just higher than what we're seeing from that ryegrass white clover feed through that springtime. What some of this component work has really highlighted, that it's important to test or evaluate these potential mitigation strategies at different time points through, during the season. We may see a different effect, as we've seen with the plantain, when we're comparing it to the spring ryegrass white clover, as opposed to what we see through that autumn period. So there's been obviously work done in Ireland, work done in New Zealand, and leveraging from this, we have a New Zealand-Irish collaborative program, which is called Emissions for Pasture. Now, this is a 4-year program, and it's been funded by from DAFM in Ireland and MPI and NZAGRC in New Zealand. Now, the key objective of this program was to really understand those methane emissions from pasture-based systems. Key focus on that pasture seasonality. And also, across that season, looking at different pasture species, so clover, plantain, different pasture quality, and then also really importantly is, understanding what is the response to other technologies, such as feed additives, across the season. And I think contrary to what we've believed before, the data from these grazing studies is indicating that in that springtime, we've got a lower methane emission, and potentially, has been mentioned, due to that higher rumen passage rate, we may actually see a lower response to some of the rumen-based, methane inhibitors during that period. So if we're looking at putting in a bolus, to reduce methane that may be effective for 3 to 5 months, potentially targeting that spring period where we may see, sort of peak intakes and peak production, may not give us the biggest response as far as methane mitigation goes. So there's one trial that's been underway at the moment, and this forms part of Jessica Dalton's PhD. This started in August last year. And in order to try and understand the impact of the cow and the diet, we've got 2 herds of cows that have been used in the study. So a lot of the previous work that's been done investigating methane emissions from cows in spring has also had early lactating animals. So we're not sure what's come from the spring pasture per se, or the combination of animals being in early lactation at that time. So in this study, we had 2 herds of cows, one that had calved in autumn, so that was sort of February, March, and one that calved in spring, being July and August. So these cows were grazing the same pastures. So you can see in this picture here, we've got the spring calved cows closest to us, and then further back in the photo are the autumn calved cows. We had 45 of these cows in each treatment, and they had access to 2 green feeds throughout the season. What we also did is at 4 time points during the year, a subset of these animals were brought indoors, and this allows us to then get more intensive methane measurements, but also to actually measure their dry matter intake. So they were brought indoors for 4 weeks in spring, 4 weeks in summer, 4 weeks in autumn, and 4 weeks in winter. So we're only halfway through the study, so I'm just going to present some preliminary data, but we've still got we've just finished the autumn period, and we've still got the winter period to go. So if we take a look at this table, this is the preliminary results from the spring period. So in the top line there, we've got the cows that calved in spring. So at this point, they're in early lactation. The bottom line is the cows that had calved in autumn, so they're in late lactation. What we can see here is dry matter intake was actually very similar, and it's been interesting to look across the different studies and see that we don't see big differences in intake. We often assume that early lactating animals are eating a lot more. What we're seeing is they're mobilizing body condition to provide the energy for that milk production. So in this study, we can see that milk, this is energy corrected milk, was higher in those cows that were in early lactation, but we didn't see a difference in methane yield, and only a trend for an increase in methane production. What we did see, though, was methane intensity, so that's methane produced per gram of product, was a lot lower in those animals. If we flick through and look at the summer data, so in this period we had our spring calf cows from mid-lactation, our autumn calf cows were in the dry period. So big difference in dry matter intake for this study, with our mid-lactating animals eating about 20 kilos and our dry animals eating sort of 9.5. What we can see, obviously, milk production difference. What's interesting when we look at methane production is through that with those mid-lactating animals in summer, it's actually higher than what we saw through that spring period. So that's supporting the work that Ben and colleagues have done in Chuggas. Methane yield, again, really reflective of those different intakes. So animals that were eating the higher intake, 17.8 grams methane yield. Animals that were eating that lower intake, so this is the exact same feed that they're eating in this instance, 25 grams. And I think that's really important when we go back and look at some of the data sets, are those intakes reflective of grazing lactating animals? Methane intensity is obviously higher for those for the mid-lactating animals, as opposed to what they were doing back in early lactation. So just pass back over to you, Ben, to have a talk about one of the other trials that's happening in that Emissions for Pastures program.
Yeah, so thanks, Jane. This is the second half of Jessica Dalton's PhD. So Jane went through the first half for thesis there, but this is the study that's currently ongoing. It's actually due to finish tomorrow. So we had set up an experiment where we essentially had deferred grazing in the springtime of pasture that wasn't touched. It was grazed in the autumn of last year. So it would have been November in Ireland in 2024. That's the treatment on the left-hand side, and we had another treatment on the right, which was pasture managed to a high quality in the springtime. So, been really setting it up for grazing or zero grazing in the second rotation, to generate big differences in pasture quality, to try and understand those differences we're seeing in the spring period, and why we're getting low methane conversion factors and lower methane yield values in the springtime, because ultimately, if we want to incorporate this seasonal effect into inventory, we want to be able to understand what's going on, and we don't want to just put numbers in without having an understanding of the mechanisms behind it. So here, yeah, we're really looking into generating big difference in pasture quality. Because just anecdotally, just looking at some of the research, maybe where there wasn't a spring effect noted, some of the pasture can potentially be quite high herbage mass and maybe of poor quality compared to the pasture, you know, that you might see in commercial practice, and maybe representative of dairy farms, as Jane mentioned, you know, commercially out there. So as part of the study, the pasture has been zero grazed into animals on electronic feed bins with a green feed indoors, and methane has been measured, dry matter intake's been measured, so we'll have a very precise value for dry matter intake. And we've also cannulated animals been used as part of the study, where we're evaluating the volatile fatty acid profiles and the rate of digestion, digestibility, and the rate of passage of the feed through the cow's rumen throughout this period to try and get a deep understanding into the effects. So we're going to continue this into the summer and the autumn. We're going to have, continue to have high and low herbage mass to continue to evaluate and follow the trend and see how it influences the methane emissions. So that's the pasture quality trial. And then if we just finish up, I suppose, just a summary of the research, then I suppose we've been conducted in New Zealand and Ireland. Look, there's a significant body of work ongoing, which is measuring enteric methane emissions from grazing cows. In these systems, you know, in reflective scenarios of seasonal pasture-based systems within both countries, and generating, you know, more granular data for enteric methane output. And, you know, the results indicate there's a strong seasonal component to enteric methane emissions, and it can change considerably throughout the production season and throughout the grazing season as well. There's more work is needed to get you know, a better understanding into the interaction between feed intake, you know, diet quality, and the composition of that diet, you know, to further refine our inventory models and, you know, help us move forward from our current, you know, level of methane prediction in both New Zealand and Ireland, which is, I suppose, an intermediate level of complexity, to more mechanistic understandings and models. And this is ongoing through the likes of the Emissions for Pasture project. And then, I suppose, to develop those methane conversion factors which can accurately predict those base emissions. So the dairy industries in Ireland, New Zealand have more accurate profile of the base methane production profile for an average cow in both systems, you know, consuming feed that's reflective of that system. And then ultimately, then we're aiming to develop those tailored mitigation strategies for pasture-based systems through the likes of inhibitors, genetics, and to get a better understanding of how they interact with that seasonal profile. So thanks very much, and we'd be happy to take questions. And just acknowledge our all our various funders as well, you know, for being able to conduct this research. So we're very grateful for all support and funding for this research.
Thank you, Ben and Jane. An excellent presentation, and I see we've got lots of questions lining up. So to enable me to have a bit of time to try and synthesize some of the questions, I'll ask one of my own. What struck me, particularly from your work, Ben, was the variability. Not even when you've looked at spring, summer, I saw values going from 0.46 to 0.68. And I really like to ask you, how much of that variability could be due to you've got to estimate intake using alkanes? And I know that happens in you've also got a measurement technology. You've got different levels of intake. You may have different quantities of feed. So how do you disentangle those whole, you know, series of potential influences and really come up with any answer that says we can definitively say that there is a seasonal pattern here? I'm really struck by the variability, even when you look to be using the same conditions. So how much do you think those other things are contributing to this, and what is the real difference? And should we be looking more closely in more highly controlled conditions so that we are confident in intake, we are confident around our measurement technologies, etc.?
Yeah, no, that's a very good question, Harry. Just going back to that value, that I suppose meta-analysis. Look, there is a range of different measurement methodologies in there. We have SF6, you know, respiration chambers, green feeds. there's a range of different, dietary conditions in there. There's different levels of concentrate being fed. There's different, different types of pasture. There's different animal genetics there. And there's no doubt all those different parameters can conduct itself to variability. It would be the same profile for milk production or intake there, so there is a proportion of variability. But what we did find is actually the level of variability or the uncertainty from those different studies is actually lower than what the current value for the IPCC is. So, that's one of the key characteristics for the IPCC for country-specific data to show that what you're presenting is, there's less uncertainty there. So we showed that as part of that study, or in that meta-analysis. And then the seasonal component, and I suppose the change in intake and your query about estimating intakes across the grazing season using the like of alkanes as markers. Unfortunately, we can't directly measure intake of grazing animals. We have to use estimations. Alkanes have been proven to be as accurate, as cutting whey in controlled conditions indoors. So, there is research out there showing that. But to take it a step further, as part of that emissions for pasture project, we are directly measuring enteric methane emissions and feed intake in a controlled environment. And I think Jane's work suggests, when we have direct measurements of intake, in that scenario, we're still getting those lower methane values in the spring. So I would be quite confident that our values in the spring and the methane yield values are lower compared to other times of the year.
And if I can just add to that, I was just going to add to that, Harry, and that a key part of the Emissions for Pastures program is to pull all this data together at the end. So the idea is that we develop what we're calling a grazing cow database, which will be looking at all of those factors to, as you say, each study can be a little bit different. When we're looking at pastures, particularly in the Waikato here, each year, we can have slightly different composition of pastures in the same season. So the idea is that with all of this data that's been collected, it'll be pulled together into a database and really dive in to look at those factors. I think what we're seeing is that the composition of the feed in that springtime combined with the intake levels and the physiology of the animal, we are seeing those low emission methane emissions during that period, and that sort of come out across all of those studies, even with a little bit of variability in data, but that database will allow us to really delve into some of those factors and nuances from this research.
Yeah, I suppose what prompted me, sorry to come back, was that when I look at data coming from respiration chambers with pasture-based diets, it's usually in the 21 to 23 gram methane range. And I notice your data, Jane, from green feeds and at pasture, it's coming in more that 18, 19, and similar to yours, Ben. And I just wondered how much that the methodology of measurement is not whether it varies with the pasture type or chemical characteristic, but are we picking up a big difference between respiration chamber values and green feed values in those absolute values, and which are massively important for the inventory?
Yeah, it's a great point, Harry, and we know that the green feed's been validated against respiration chambers. I think there's other factors in play as well. So when we've gone back and looked at some of those other data sets through respiration chambers, and I think the pasture quality and the intakes are quite different as well. So it's really hard to separate out what's an equipment difference versus what is what's an animal and feed factor. So we still get higher levels. I'm not sure if you saw when our dry cows were fed sort of 9-10 kilos of pastures. We're getting up around 25 grams of methane per kilo of dry matter intake, and that's really sort of feeding into that story that it's been driven by that passage rate in the rumen. We've done some silage work as well, and Ben will be able to talk about this with green feeds and have got those higher measurements as well. So I think it's something that we need to do. We've gone back and looked at some of those data sets, and when the average intakes are low and pasture quality, particularly NDF, is higher, that's when we're seeing those higher methane values. So really hard, I think, to separate out what is an equipment effect versus what is an animal and a feed effect between those studies. Ben, I don't know if you want to comment.
Yeah, no, just to come in from an Irish context, just from the growing animals, we would see those values with green feed, Harry, the 23 to 25 grams per kilo of intake, on pasture, so there's and just, yeah, it's just seems like those values for lactating cows, we seem like we're getting those lower values. But yeah, just that's what we would find.
Thank you. That's really great answers. I'll just move on to some of the questions, and we've got quite a few. I'll try and work through and summarize these. Evening, Carl. Thanks for your question. It's Carl Richards from Chuggers. Could you please comment on the importance of considering the effects of different forage qualities that might be observed on real farms rather than research farms? And also a supplementary, what methane conversion factor might you expect to see on lower nitrogen input farms? So there's two questions there.
So no, that's a good question. Yeah. So look, as part of the research, we're collecting data in a research setting and generating these methane conversion factors. So, it's very important that the diet of those farms is reflective of what would happen out commercially. So as part of a report we would have written for our inventory, we would have included commercial data in it. There's 5 different studies and 2 parameters which really they focus on. The IPCC is the level of NDF at the diet and the digestible energy content of the diet, or percentage digestibility. And we've seen across the research and commercial farms, the NDF and digestible energy contents were quite comparable. They were actually very, very, especially digestible energy, they were on par, and NDFs, there was only a small percentage difference between them. So yeah, we'd be confident that commercially the pasture quality would be reflective of what would happen, in research farms. In terms of a nitrogen input system, there has been some research done in the Netherlands. There has been a whole lot done in nitrogen, and I just aware of some zero grazing work, and nitrogen didn't impact the methane conversion factor or methane yield value. So just based on that research, I wouldn't say it has a large effect. But again, it's from one study.
Do you have anything to add, Jen? Are you happy with that answer?
No, I agree, and what we'd like to do now is a lot of this research is, as I said, is being conducted up in the Waikato. So the plan is to look, South Island with irrigated pastures. I think we'll see even higher quality for longer periods. So I think important to understand the seasonality effect in the different regions, which would be reflective of commercial farms in those regions.
Yeah. Okay. I've just got one in here on the silage, and I'm trying to amalgamate a couple of questions. That given that there's such huge variability often in pasture silage in its composition and its quality, how do you find an average value for silage?
I'll just go, yeah, look, the silage we fed in that study there would have been reflective of the silage fed on farm in Ireland. And silage can vary a lot in quality. If you very high quality silage, you're going to get a lower methane yield value. So we found in that study, Michael and Mike, found that, when you fed average quality silage to what we fed on farms, there was a higher methane yield and conversion factor. But there is a large amount of variability due to weather conditions, the cutting, growth stage, all those different factors. So it's very important to be able to capture those effects and make sure it's counted for in inventory if there is variability there. But from average silage quality, on farm it was higher. That would be reflective on farms. Yeah. So.
Jane?
Yeah, I mean, I agree. It's a good question. There will be variability, in any unsold feeds. I think ultimately, with more research being done, we can come up with a default value. I think the granularity that we'll be able to get to in some of these inventories there'll be a barrier to that. We can't have a value for every different type of silage, but I think if we can understand an average or a default value, I know some of the farm emission modelling, or inventory, there may be the ability to be able to enter your own data in that at some point. But at this stage, I think understanding those differences, between types of feed and between seasonality, we're seeing large differences, is important. There will be a limit to the sort of granularity that we can get to in these inventory models.
Just to follow on from Jane's point, sorry, I just think that's a big challenge in terms of our pasture-based systems, because of that, just even looking at pasture, the variability in pasture quality and quantity, and just maybe following on more detail on Carol's question, like the likes of the Netherlands indoor systems have these great banks of information on feed quality of farms. They're able to move to these tier 3 advanced models. So from our perspective, in Ireland, New Zealand, we can generate these, prediction models, all these mechanistic understandings with NDF and all. But ultimately, if we don't have that values coming from different farms and it's changed from year to year, it's impossible to actually utilize them. So a big challenge I think we have from this space and moving to more accurate emissions monitoring is that feed quality space and that picture to generate it. And I think that's a very important future area of research, to be able to generate that data.
Thank you. This is a summary of a number of questions. So you looked at the difference between grass and grass clover and didn't really come up with any differences. The question is really, have you looked more broadly at how pasture species and even mixed species swards influence the absolute levels of methane emissions?
Do you want to comment? Yeah, do you want to comment first, Jane?
I can comment on that. So we haven't done a lot of work thus far, but it's definitely planned looking forward. So we've looked at plantain, and we've looked at Alina, Monet and the team have looked at that at a sort of at 40% of the diet, at 80% of the diet. But there is plans going forward to have a look at the methane emissions from some of those mixed pasture species.
Thank you.
And from an Irish perspective, we would have looked at just plantain grazing, and we would have seen lower methane per cow per day. We were waiting the dry matter intake results, so we don't know what it did to methane yield. And we also looked at the incorporation of a mixed species sward with plantain, some chicory, red and white clover into a grazing sward. And we observed similar methane emissions, but higher milk solids production, higher intake, so a lower methane intensity, or methane per kilo milk solids, lower methane yield with that sward.
Yeah, thank you. I've got a complex question here. I have to read this one out. It's really to something you said, Jane. It said, with indoor diets, and this is thanks to David Pacheco from New Zealand, with indoor diets, the relative reduction of some feed additives is greater as the ratio of starch to fiber increases. This has been attributed to digestive aspects such as the rate of passage, fermentation profiles, pH, etc. You mentioned that with pasture, you thought the potential effect of an additive may be reduced in spring, which contrasts with results from indoor trials that indicate that less fiber, more fermentable carbohydrate leads to greater responses to methane inhibitory compounds. Can you explain why you expect it to be different?
Yeah, and that's a great question, David. And we've had quite a lot of discussion about this, because if you look at what's happening through that spring period, you do have high quality, higher starch pasture. So based on some of that work, I know Sane Van Gastelen and that, where they showed an enhanced response to I think it was 3-not, to a feed additive at that time. What we think, and that's why there's a research project plan to look at this, is when a lot of those feed additives are very transient in the rumen. I know Ben and his team have done work and shown in that sort of first hour you'll get a good response, but that declines over time because of that rumen residence. We're seeing very fast passage rates through that spring period, particularly due to the higher intake and the lower dry matter of feed at that time. So I think my thoughts are that the transient nature of the feed additives and the very fast rumen passage rate during that spring period will reduce the efficacy of them. But yeah, we've had that same debate because on the other hand, the higher feed quality and the higher starch theoretically should increase the response to it. So that's why it's important to go in and test it. Ben, I don't know if you want to add add to that?
Yeah, no, just I agree. It's kind of we don't it's like we can try to guess what's going to happen, but really we won't know until we do the experiment. But yeah, the higher feed quality should theoretically maybe improve the efficacy, but as Jane rightly pointed out, the higher rate of passage may also have a negative effect on the efficacy. So yeah, and it'll be very important research and interesting trial to do.
And I think if we look at, what's coming out of, Ben's seasonal work and, back to Robertson and Waghorn's paper and our work, we're seeing lower total production of methane at that period. So if we're looking at cost effectiveness and, what it's going to cost to put an additive or a bolus in, when are we going to get the best reduction? So that's, I think that's really important across our season to tailor our mitigations to, theoretically get the best bang for buck when we're using these additives or inhibitors.
A really practical question. This is asking you to be a bit crystal ball gazing, but from your work at the moment, could you suggest how cows can best be managed to reduce emissions? That you've looked at you get these numbers, which might be fine for the inventory. Does it give you clues as to how best to manage animals so that you can get the lowest absolute emissions and the lowest emissions per kilo milk solids? Very practical question as to where your research is leading.
Maybe I just go from an Irish context. Look, I think really what it shows is the importance of, from a basic principle of getting more grass into the diet, making sure you have good grazing infrastructure on farms. You're able to get cows out grazing in the springtime. It's the lowest methane feed there. It's a lot lower than silage. Well, the average silage you might have on farms. And making best use of that grass can reduce methane emissions. And really continue to do that, optimizing the system, from a fertility perspective, having less replacement animals in the system, higher production from grazed grass, less inputs of emissions coming into the system through fertilizer and concentrate inputs, so you're reducing your total carbon footprint. Really it's simple and effective ways, can help improve performance and reduce emissions intensity and overall emissions. I don't know if Jane, you want to comment?
No, just add to that the importance of that pasture quality throughout the season. And we know that, if you're managing your pasture well in spring, you will end up with, higher pasture quality through the remainder of the season. Also, I think another area we're really keen to dive into a little bit more is, genetic merit. So high genetic merit animals, is that opportunity, as you say, to harvest more pasture, produce more milk, and reduce emissions that way.
Okay, we've got 2 minutes left, and so I'll try and finish 1 minute before you've got one last question. Be very quick. In both of your system descriptions, you showed that you use concentrates at various times of the year, but you haven't actually talked much about how much or what type of concentrate is used could be influencing the emissions. Could you very quickly comment on that? And as I said, you've got about a minute between you.
I'll go really quickly and leave time for Ben, but yeah, absolutely. There's work that's done, as I think David pointed out, that higher starch can reduce emissions. What we've seen is there seems to be a seasonal effect of that. So we've added concentrates in that spring period. We're not seeing the same potential mitigation as we would later in the season, and we've actually got some trial work planned for this coming season in New Zealand here to really try and understand the effect of supplementation throughout the season to be able to come up with some values on that.
Just my comment, yeah, concentrate can definitely influence methane output, especially maybe if the base diet is of a poorer quality. But it's also very important to be considered that although it could reduce methane intensity in those scenarios on the day, you also have those emissions depending on where that source feed is coming from. From an LCA perspective, you could have increased emissions coming onto the farm. So it's just important to avoid pollution swapping,
Well, thank you very much. That's been a wonderful presentation and a wonderful set of answers and discussion afterwards. So thank you both. I thank everyone for attending, and it's goodbye from the NZAGRC and our representatives from Dairy NZ and Choggers.